Hey everybody, this is Mr. Longo, and in this video we are going to cover multi-trig evaluating type problems, which basically means you are going to have to evaluate two different trig functions for every question. And sometimes you're going to be doing inverse and then standard evaluate. Sometimes it's the other way around. Sometimes it's multi-evaluating, adding, subtracting, multiplying, something like that. So these questions are basically requiring you to be an absolute ninja when it comes to being able to evaluate trig functions in both radians, degrees, and also going in the inverse direction. So let's start by the first example to give you an idea of what I mean. What you do when you're having a multi-step evaluate type of problem, the first thing you have to do is what's inside the parentheses. If it's one of these, evaluate an inverse, or take the inverse of an evaluate. So the cosine -1 of root 3 over 2. So where is cosine equal to root 3 over 2? And cosine inverse is at 30 degrees. So now what you're doing is taking the sine of 30 degrees. And the sine of 30 degrees is at 1/2. So if you are having trouble visualizing this, you most definitely want to get out your unit circle to be able to reference it. But basically what just happened is this. Where is cosine root 3 over 2? That's when x is root 3 over 2 right here at 30 degrees. And what is the y value? What's sine of 30 degrees? That's 1/2. Okay, that's how we did that first question. Let's try again. Second one. When is tangent -1? Okay, so tangent is 1 at 45, but inverse, remember, we use the negative reference angle. So tangent of -1, or inverse tangent of -1 is at -45 degrees. So what you're doing now is taking the cosine. So down here, the cosine, or your x value, is root 2 over 2. Okay, so you're working in both directions. That's how you work with these types of questions. Now, if you're feeling pretty good about the unit circle, since we just covered a whole bunch of it in basically one-step questions, go ahead and pause the video, see if you can continue on your own. If not, let's go. So what we're going to be doing for this question is taking the cosecant of inverse cosine of negative root 2 over 2. So cosine is equal to a negative root 2 over 2 at 135 degrees. Remember, negative cosine values take place in quadrant 2, so that's 180 minus your reference angle of 45. Cosecant of 135 is the reciprocal of sine. So sine of 135 is equal to root 2 over 2. So the reciprocal of that would be 2 over root 2. And I'm fine if you leave it that way, but if you are asked to simplify and rationalize your denominator, it would just become 2 root 2 over 2, which is just root 2. Number 4, what is the cosine of 11 pi over 6? So if you were to draw 11 pi over 6, that's going to put you over here with a pi over 6 reference angle. The cosine of pi over 6 is root 3 over 2. Since you're down here, it's the same because cosine is still positive. So this is going to become inverse sine of root 3 over 2. And where is sine root 3 over 2? Sine is root 3 over 2 at 60 degrees, which is also known as pi over 3. Now, the directions should tell you if your answers are supposed to be in degrees or radians, but I'm just going to work with both just to help give you extra practice with each one. On to number 5. Number 5 says, what is the inverse sine of tangent of pi over 4? Well, the tangent of pi over 4 is 1. So what is inverse sine of 1? So where is the y value 1? And that is at 90 degrees, also known as pi over 2. Number 6. This is an example of multi-stepped evaluating, but then you're going to multiply your results. So what is the sine of 45? Sine of 45 is the y value, which is root 2 over 2, times, what is the cosine of 60? The cosine of 60 is 1/2. Now all we're going to do is multiply those together. Remember, when you're multiplying fractions, root 2 times 1 is just root 2. And 2 times 2 is 4. And then you would simplify if you can. You cannot simplify here. Remember, you cannot simplify the inside of a radical with a number. So you are done right there. So your answer is root 2 over 4. Next example, what is the cosine of negative pi over 4? So the cosine is your x value. It is still positive in quadrant 4. So that's going to give you root 2 over 2 times, what is the sine of 5 pi over 4? So 5 pi over 4, remember, is down here in quadrant 3, which is where sine is negative. So sine is root 2 over 2 at pi over 4. So that's going to give us a negative root 2 over 2. And now you would just multiply those together. Root 2 times a negative root 2 is a negative root 4. Over 2 times 2 is 4. The square root of 4 is 2. So this is going to give you negative 2 over 4, which can be reduced to negative 1/2. Okay, so again, being able to work with the unit circle gets you the first part. You still need to be able to work with fractions to continue on through. What is the sine of 45? The sine of 45 is root 2 over 2. Plus, what is the cosine of 120? So remember, 120 is going to be over here with a 60-degree reference angle. So that's where your cosine value is equal to 1/2. But since cosine is negative here, this is going to give us a negative 1/2. And then you just have to simplify. Now remember, when you are adding and subtracting fractions, you need a common denominator, which we do have, but we cannot subtract numbers from radicals. So our answer is simply root 2 minus 1 over 2. Proper notation would be negative 1 plus root 2 over 2, because whenever you're writing in terms of numbers and radicals, the numbers should come first. And our last two examples. These, you have a multiplier. So this basically means what is 3 times the sine of 1/2? I mean pi over 2. The sine of pi over 2 is up at the top, so 3 times 1 minus what is the tangent of pi? Your tangent of pi is 0, so this answer is just 3. And the last example of this set is 2 times the secant of 60, which, remember, is the reciprocal to the cosine of 60. So the cosine of 60 degrees is 1/2. So the reciprocal is going to give us 2 times 2, which we have is 4, plus, what is 3 times the cosine of 135? So 135 is over here. Reference angle is 45 degrees. So cosine of 45 is root 2 over 2, but it's negative there. So this is 3 times negative root 2 over 2. And that's going to give us plus, or we could actually just change this to minus 3 root 2 over 2. But in order to add and subtract fractions, you need to change this to a common denominator. So we're going to multiply both the top and bottom by 2. So this is going to give us 8 minus 3 root 2 over 2. Okay, that's it for multi-step evaluating. This is Longo and I'm out. See you, bye.